Okay, this video is a quick rundown of all the monocular cues humans use in order to judge distance visually. Also in this video, we will be discussing the basics of motion perception. First of all, you have the relative size. When humans see two objects that are similar in size, they perceive that the object that is bigger to be closer. Look at these two Snapple bottles. Yes, they're random, but look at these two Snapple bottles. The one closest to the camera should appear as though it is larger than the one smaller from the camera. Next, we have interposition. This is the instance where one object partially blocks the view of another object. You can see here that the bottle of Snapple blocks the view of the ketchup. See that? Partially blocking the view of the ketchup. This tells the eye that the tea is closer than the ketchup. Moving on to relative clarity. This monocular cue is slightly more difficult than the previous two, so hang with me. This is the fact that light from objects farther away passes through more atmosphere than objects that are closer to the human eye. This makes them look hazy and farther away, and as opposed to an object that is closer is more clear to the eye. For example, if you're standing in the road in the middle of the desert and you look far down the road, you see an object and it looks kind of blurry. You know what I'm talking about? Like a scene from a movie? Well, yeah, relative clarity. Hi. This next monocular cue is called texture gradient. This is where a distinct texture becomes an indistinct texture. This same texture makes the indistinct object look farther away, while the distinct object seems to be closer up. If DaQuory would kindly show you the picture in the textbook. This is the best picture I thought to explain texture gradient. Alright, see here? This pattern is closer up, and it is more distinct than this black area in the middle, which is less distinct. And you cannot see the pattern near as clearly. And then moving back in this direction, distinct, you can see the pattern easily. And then as you move into this black appearing abyss area, it is less clear. Texture gradient. Alright, now I want to explain the monocular cue relative height. Humans perceive objects that are higher in their field of vision as farther away. This could be a reason that we tend to believe vertical measures are longer than horizontal measures. Now, once again, I need DaQuory to reference the picture in the book, please. As you can see, the relative height by the human eye appears to be taller than this vertical distance, even though I measured and they are the same length, because the book says to measure, book says to measure, and so I tried measuring, and yeah, same distance, height looks taller. Hi, I want to talk to you about the sixth monocular cue. It's called relative motion. This happens when someone sets their gaze on one specific object. Okay? While you have your gaze set on that one specific object, objects that are beyond the object seem to move with you as the gaze is set on one object. And items that are in front of you seem to move past, like back. For example, if you set your gaze on a house, here comes a house. Try to set your gaze on the house. Items such as the sky in the background should appear to move along with the camera, or with aka your eye. And also, items that are in front, aka mailboxes, trees, grass, and plants, appear to move backwards. And I will, after we get back to the house, we will reference that with a picture to make it a little bit more clear. But yeah, I just wanted to try and give a real life example. I'm out. Wait. All right, as you can see, this chick is looking out the window right here. She's looking out the window. The sky, here's the fixation point. She's got her eyes fixed. Yeah, it's kind of blurry. You can't really read that, but it says fixation point. Sky moves along with the car. Plants and stuff like that moves backwards. Yep. Next, we have the linear perspective. This is a fairly simple monocular cue, just because it is. All right. This one states that two parallel lines they'll always be parallel. But as they go on farther, they will appear to converge closer together. For example, if you were standing on railroad tracks and you looked for miles in a straight line down the railroad tracks, they would appear as if they're coming closer together. What up? Light and shadow is the last monocular cue. This cue states that given two identical objects, the dimmer of the two seems farther away. The best way for me to explain this is for me to show you the picture that's in the book. So I'm going to show it to you. Alright, so here's the light and shadow. As you can see here, two identical circles, but this one, the smaller one, is flipped upside down, and it's smaller. Therefore, it looks as though this one's farther away. It looks like it has some depth. It looks like you can cup inside of it, but secretly you can't because it's just a photo. Perfect example. Alright, so we've covered all the monocular cues. Now for this last part, I want to talk about motion perception. And there's three really important parts to motion perception. One way that the brain computes motion is with the assumption that shrinking objects are moving farther away and enlarging objects are coming closer, to the eye. One real-life example of this is a baseball player running to catch a fly ball. So let's just say that a fly ball is hit, outfielder's running to catch it, the object's coming closer, getting bigger and bigger, and bam, he collides with it and catches it, or doesn't catch it. Hopefully he catches it. Second, another form of motion perception is called stroboscopic movement. Now this occurs when we see a series of still pictures and it looks like a regular film because there's so many pictures that it looks like a regular film. For example, SpongeBob, cartoons. SpongeBob is actually a series of drawings put together so quickly that it looks like it's just a movie. Read in the textbook that it takes 24 pictures per second to make it look like this. So that's pretty cool. Okay. Lastly, for the motion perception, we have the phi phenomenon. Maybe phi, but I'm going to go ahead and say phi phenomenon. This is where stationary lights that are together blink in succession, making it appear that there's an image on the screen. For example, Jumbotron, or a marquee sign where you see the lights flashing and you see images. So yeah, those are the three important aspects of motion perception. Deuces.